to this lesson on balancing chemical equations. Today, we'll be looking at the reaction of calcium carbonate decomposing into calcium oxide and carbon dioxide. Let's start by writing out our unbalanced equation. We have calcium carbonate on the left side of the arrow and calcium oxide plus carbon dioxide on the right side. Next, we need to count the number of each type of atom on both sides of the equation. Let's start with calcium. We have one calcium atom on each side. For carbon, we also have one atom on each side. Finally, for oxygen, we have 3 atoms on the left side in calcium carbonate, and on the right side we have 1 in calcium oxide and 2 in carbon dioxide, which also adds up to 3. Now that we've counted our atoms, we can check if the equation is already balanced. As we can see, we have the same number of atoms for each element on both sides of the equation. This means our equation is already balanced. Let's break down why this equation is balanced. For calcium, we have 1 atom in calcium carbonate on the left and 1 atom in calcium oxide on the right. For carbon, we have 1 atom in calcium carbonate on the left and 1 atom in carbon dioxide on the right. For oxygen, we have 3 atoms in calcium carbonate on the left, and on the right, we have 1 atom in calcium oxide and 2 atoms in carbon dioxide, which adds up to 3. Let's visualize this balanced equation. Here we have 1 calcium carbonate molecule breaking down into 1 calcium oxide molecule and 1 carbon dioxide molecule. Notice how all the atoms are conserved in this reaction. In conclusion, we've seen that the equation CaCO3 CaO plus CO2 is already balanced. This means that during this reaction, all atoms are conserved, which is a fundamental principle in chemistry. Remember, in any chemical reaction, the number of atoms of each element must be the same on both sides of the equation.